AI research just shifted from asking models to answer better to making them verify, coordinate, and even improve against their own evaluators. That matters because the bottleneck is no longer just raw generation, it's whether systems can judge progress, move work in parallel, and keep adapting as the goalposts change. This week's papers point to a new scaling layer for agentic AI, and the payoff is concrete: better coding, faster multi-agent reasoning, and stronger self-improvement loops. Keep watching, because the most interesting gains are happening after the model speaks. Let's explore the first paper, LLM as a Verifier A General-Purpose Verification Framework. LLM as a Verifier from Stanford University, UC Berkeley, and NVIDIA Research reframes verification as a scaling axis for agentic systems by replacing discrete LLM judge scores with the expectation over scoring token logits, producing continuous rewards without extra training. Using Gemini 2.5 Flash as the verifier, the framework scales along score granularity, repeated evaluation, and criteria decomposition, raising terminal bench 5.2 pairwise verification accuracy from 73.1% at g equals 1 to 77.5% at g equals 20, from 74.7% at k equals 1 to 77.5% at k equals 16, and from 75.2%, 76.4% for single criteria to 78.3% when three criteria are ensembled. A cost-efficient probabilistic pivot tournament reduces candidate ranking from ON2 to ONK and on to 0 candidate pools, improves selection accuracy from 64.64% for the V1 baseline at 1N budget to 67.13% at 9,630 queried pairs with K equals 9. In downstream test time scaling, the verifier sets new state-of-the-art on terminal bench 5.2 at 86.5%, SWE bench verified at 78.2%, Robo reward bench at 87,4%, and MedAgent bench at 83,3%. The same fine-grained signal also tracks task progress, reaching Spearman VOC 0.848 on successful terminal bench trajectories and 0.966 on Robo reward bench, and it improves reinforcement learning sample efficiency, giving about 1.8 times higher efficiency on Libero with DSRL SAC and about 1.1 times on math with GRIPO. Let's explore the second paper, Streaming Communication in Multi-Agent Reasoning. Streaming communication in multi-agent reasoning introduces StreamMA, a multi-agent protocol from HKUSTGZ, Alibaba Group, and Zhejiang University that replaces the usual generate then transfer rule with step-level forwarding. Each reasoning step is streamed downstream immediately, allowing adjacent agents to overlap execution instead of waiting for a full response. The paper gives a closed-form analysis of 3 execution modes: single, serial, and stream, showing that stream is optimal when early steps are more reliable than later ones, while also deriving a speed-up upper bound and an exact cost ratio under LLM serving assumptions. Empirically, across 8 benchmarks spanning AMI 2025, AMI 2026, HMMT 2026, GPQA Diamond, HLE, and LiveCode Bench, using Claude Opus 4.6 and GPT-5. For overchain, tree, and graph topologies, StreamMA improves average accuracy by plus 7.3 pp on Claude and plus 1.5 pp on GPT versus serial, with a peak gain of plus 22.4 pp on HMMT 2026. The study also reports a step-level scaling law at A equals 64, increasing per agent steps S from auto-decided length to 64, raises accuracy from 68.2% to 73.5%, and yields 26.9 times wall clock speedup, reaching 83% of the theoretical 32.3 times bound. With A equals S equals 4 on Claude Opus 4.6, the protocol achieves about 2.3 times speedup, and under full prefix caching it is 7.5% cheaper than serial, while the no-cache regime reverses that advantage. Let's explore the third paper, the Red Queen G Dell Machine Co. Evolving Agents and Their Evaluators. The Red Queen Gödel Machine, RQGM, extends recursive self-improvement to non-stationary utilities by co-evolving task agents and learned evaluators inside epoch-bounded search, so each epoch remains a fixed criterion problem, while evaluators can be replaced at checkpoints using best belief on a held-out ground truth anchor. Built on Huxley-Gödel machine and hyperagents, the method uses selective erasure to delete utility records tied to displaced evaluators and exponential checkpoints to keep transition overhead linear in the evaluation budget. In GPT-5 5-low experiments, RQGM improves polyglot coding from 69.9% to 71.7% held-out pass rate using 1.35 times 1.72 times fewer tokens, raises paper review acceptance for co-evolved writers from 21.8% to 40.5% under a 4-reviewer panel, and improves proof grading accuracy by 9% over static baselines, while using 3 times lower search cost at the best grader point. The framework also corrects evaluator bias. A paper reviewer trained with an adversarial objective reaches roughly 80% anchor accuracy while making acceptance rates for AI and human papers similar. Instead of over-accepting AI-generated work at up to 1.91 times the human rate, a cost ablation swaps search time task agent calls to NVIDIA Nematron 3 Ultra and cuts search costs by about 13 times while approaching the GPT-5 only endpoint performance, showing that most expense comes from repeated evaluation rather than expansion. That's a wrap on today's AI paper highlights. Thanks for watching.